We're going to kick off Algebra 2 with a review of some Algebra 1 concepts, starting with absolute value equations. So in this first question, we're asked, what are the solutions of the absolute value of 2x minus 1 is equal to 5? And then we're going to graph the solution on a number line. So start off by rewriting the original equation of absolute value of 2x minus 1 is equal to 5. And one of the things that we need to do with any absolute value equation is make sure that the absolute value itself is isolated, that there's nothing on the same side of the equation that is outside of those absolute value lines. In this problem, the absolute value signs are already isolated, so we can go ahead and go to the second step in solving any absolute value equation, which is splitting the equation into two separate equations. So we have 2x minus 1 equals 5, which is just rewriting the equation but dropping the absolute value signs. The next one we have is 2x minus 1 equals negative 5. So the second equation that we write is always going to be equal to the negative quantity that was on the other side of that absolute value sign. Moving on from there, we do our isolating the variable, add 1 to both sides, so we get 2x is equal to 6 and 2x is equal to negative 4. Divide out the 2, x is equal to 3, x is equal to negative 2. Now what we want to do is we want to go back and check and make sure that we did this correctly. So we're going to take our two solutions and we're going to plug both of those solutions back into the original equation. So 2x minus 1, the absolute value of 2x minus 1 is equal to 5. We're going to plug in 3, so the absolute value of 2 times 3 minus 1 is equal to 5. And the absolute value of 2 times negative 2 minus 1 is equal to 5. Multiply inside of the absolute value signs, so 2 times 3 is 6, minus 1 is going to give us 5. 2 times negative 2 is negative 4, minus 1 is going to give us negative 5. The absolute value of 5 is 5. The absolute value of negative 5 is 5, and we know that 5 is in fact equal to 5, so our solutions are correct. To finish off the question, we're going to go ahead and plot both of those points, and you can see as the number line comes up that we put one point at negative 2 and the other point at 3, and that's all we've got to do to graph it. In our second problem, we're looking to solve a multi-step absolute value equation. The question is, what are the solutions of 3 times the absolute value of x plus 2 minus 1 is equal to 8? And again, graph the solution. So rewrite the original equation, and in here we see that we've got a 3 that is being multiplied against the absolute value and 1 that is being subtracted from it. So we've got to go ahead and isolate the absolute value first before we can do anything else. So use your opposite of the order of operations, add 1 to both sides. 3 times the absolute value of x plus 2 is equal to 9. Divide out the 3. Now we have an isolated absolute value of x plus 2 is equal to 3. Take the absolute value equation, split it into 2. X plus 2 is equal to 3, and x plus 2 is equal to negative 3. Subtract 2 from both of our equations. We end up with x equals 1 and x equals negative 5. To finish this problem off, go ahead and plot 1 and negative 5 on the number line, and we're done. In the first problem of this section, I asked you to check your answers to make sure that you had done all of your work correctly. There are going to be times when you're doing absolute value equations when you have to check your work for another reason, and that's to look for extraneous solutions, or things that look like they're answers but really aren't. So we're going to look at what are the solutions of the absolute value of 3x plus 2 equals 4x plus 5. Again, with this equation, the absolute value is already isolated, so we're going to go straight to breaking the equation into 2. 3x plus 2 equals 4x plus 5. And 3x plus 2 equals negative quantity of 4x plus 5. Notice that in this second equation, we've got the negative multiplied against the entire quantity. You have to multiply the negative 1 through all the terms in order to do these correctly. So that leads us to to an intermediate step, which is going to be the distribution. So we get 3x plus 2 equals negative 4x minus 5. Now the next thing that we need to do with both of these equations is to move the smaller variable to the other side, because we do have variables on both sides. So in the first equation, that's going to be the 3x, and in the second equation, that's going to be the negative 4x. So we need to subtract 3x from the first equation and add 4x to the second. That's going to leave us with 2 equals x plus 5, and 7x plus 2 equals negative 5. At this point, we just go back to our isolating the variable. So subtract 5 from the first equation and subtract 2 from the second. When we do that, our first equation is finished off with x equals negative 3, and our second equation moves on to 7x equals negative 7. Divide out the 7, and you end up with x equals negative 1. At this point, you need to go ahead and substitute both of your solutions in to the original equation to check for extraneous solutions. So we're going to get the absolute value of 3 times negative 3 plus 2 is equal to 4 times negative 3 plus 5, and then also the absolute value of 3 times negative 1 plus 2 is equal to 4 times negative 1 plus 5. Now 3 times negative 3 is negative 9, plus 2 is negative 7. 4 times negative 3 is negative 12, plus 5 is negative 7. So you can see we get the absolute value of negative 7 equals negative 7. In the second equation, 3 times negative 1 is negative 3, plus 2 is negative 1. Then 4 times negative 1 is negative 4, plus 5 is 1. So we get the absolute value of negative 1 equals 1. Now, one key thing that you need to remember about all absolute value equations is the absolute value, an isolated absolute value, cannot be equal to a negative number. So if we look at that first equation, the absolute value of negative 7 equals negative 7, we already know that this is not a solution, because what is the absolute value of negative 7? It's 7. And 7 does not equal negative 7, therefore negative 3 is not a solution. Over on the other equation, the absolute value of negative 1, that is 1. So 1 does equal 1, which means that the answer that we plugged in there, negative 1, is a solution to the original absolute value problem. And interval notation is going to be something that may be completely new to you, that you've never seen before. So the way that this is going to work is we're going to look at our sign, how we traditionally graph it with the circles, and then how are we going to graph it using interval notation, or how are we going to note it using interval notation as well. So our first sign is the less than sign. And traditionally, with a less than, we would have an open circle with the arrow pointing left. Now, what we're going to replace the open circle with is a parenthesis. So in this case, if you had, say, x is less than 3, you would have your open circle at 3, and it would be going to the left. That arrow pointing to the left is representative of negative infinity. So whenever we do interval notation with a less than sign, we're going to have an open parenthesis followed by negative infinity, comma, and then whatever that number is where the circle is, or where the circle would have been. And then because you had an open circle, we're going to use a closed parenthesis to finish off the interval notation. So if it was x is less than negative, or x is less than 3, you would have had open parenthesis, negative infinity, comma, 3, close parenthesis. For greater than, what we're going to do with this is we're thinking of, okay, where on the number line would our circle be in relation to the arrow? So in this case, the circle would come before the arrow, and that's the way that we're going to do the interval notation as well. So if we had x is greater than 3, what we would do is we would use the open parenthesis. And again, remember the open parenthesis is representative of the same thing that the open circle is representative of, which is to say that that particular point on the number line is not a solution to this inequality. So if we were to use x is greater than 3, we would have open parenthesis 3, comma, And then where is that arrow pointing to? It's pointing to infinity. So infinity, close parenthesis, and that would be our interval notation for that. Now less than or equal to. With less than or equal to, again, thinking on the number line, what comes first? In this case, it's the arrow. Then it's the closed circle. So what we're going to do is we're going to, since the arrow comes first and it's pointing to negative infinity, we're going to use open parenthesis, negative infinity, comma, our point where the closed dot would have been, which we're just going to call x. And because it's a closed circle, we're going to use a bracket. We're going to close it off with a bracket this time. That bracket indicates to us that that number that is in the place of the x is in fact part of the solution. Moving on to greater than or equal to, same thing. Where is the dot in relation to the arrow? In this case, the dot comes first, so we're going to use an open bracket followed by x or whatever number that point represents, and then comma, infinity, and the arrow indicates to us that it's going off to infinity, so then we're going to use a closed parenthesis. We're going to use interval notation to graph in this next problem. So we're looking at solving the absolute value inequality. The absolute value of A is less than B. And the question is, what are the solutions of the absolute value of 2x minus 1 is less than 5? Graph the solution. So our absolute value has already been isolated, so we're going to go ahead and split this into two separate inequalities. Our first inequality is going to be 2x minus 1 is less than 5. So it looks exactly the same as the original absolute value. All we've done is drop the absolute value signs. The second inequality is going to be 2x minus 1 is greater than negative 5. So what we've got to do is flip the sign and make the quantity on the right side negative. Now in both inequalities, we need to add 1 to both sides. So we're left with 2x is less than 6 and 2x is greater than negative 4. Then divide out the 2. X is less than 3, and x is greater than negative 2. So at this point, treat these as if they're equations. X equals 3 and x equals negative 2. Plot those points on the number line. So you're left with x is at negative 2, and x is at 3. Now, instead of using dots, because we've got less than and greater than, but not equal to, we're going to use parentheses instead. And what we're going to do is we're going to have the parenthesis open up in the direction that the arrow should be going. So because we've got the variables on the left side in both cases, that means that our less than and greater than signs actually point in the direction that the arrows need to go. So for x is less than 3, that arrow is pointing, or that less than sign is pointing to the left, so that means our arrow points to the left. For x is greater than negative 2, since we've got the greater than sign pointing to the right, that means our arrow goes to the right. So the parenthesis at negative 2 opens right, the parenthesis at 3 opens left. Then the arrows go in opposite directions but towards each other, and it's that area in between the parentheses that is going to house all of the solutions. For the next problem, we're going to try the same thing, except we're going greater than or equal to b instead of less than b. So what are the solutions of the absolute value of 2x plus 4 is greater than or equal to 6, and graph the solution? Once again, that absolute value has been isolated, so we skip to step 2, which is going to be to split it into two separate inequalities. So we've got 2x plus 4 is greater than or equal to 6. Again, all we've done is drop the absolute value signs. And 2x plus 4 is less than or equal to negative 6. We've flipped the sign and we've made the 6 negative. Subtract 4 from both sides. 2x is greater than or equal to 2, and 2x is less than or equal to negative 10. Then divide out the 2. X is greater than or equal to 1, and x is less than or equal to negative 5. Now in this case, what we're going to do is we're going to take a look at that x is less than or equal to negative 5. we're going to plot -5 on the number line, but instead of using a dot, we're going to use a bracket because the bracket indicates that this is less than or equal to. So anytime that we've got any sort of equal to, we're using that bracket. And since that arrow is pointing to the left, that is the direction that our arrow is going to go on the number line. Then for x is greater than or equal to 1, we're going to plot at 1, but we're going to use a bracket instead of a dot. And then that arrow is pointing to the right, so our arrow is also going to go off to the right.